Hi, I'm Scott Hunter, the Director of Program Management at Microsoft on the .NET platform. And I'm excited to be here today to talk about the future of .NET, and especially .NET 5. Let's get started. First off, .NET has grown leaps and bounds over the years. When we first started off, we only did web and desktop, and we've added cloud, mobile, gaming, IoT, and AI over the last couple of years. And so now we think it's the platform where you can build anything. When I think of the ecosystem of .NET, how is .NET doing in the world? We've added 1.5 million .NET Core developers since 2017. In the Stack Overflow Developer Survey, we are the #1 most loved framework 2 years in a row. And we just open sourced in 2014, but since then, we've been one of the highest velocity projects in GitHub when it comes to contributions, issues, and those things filed. And then we're also the top 5 language in GitHub as well. And performance has been a huge part of our platform since we announced .NET Core a couple of years ago. And we are faster than Node.js by 7 times. We are in the top 10 of almost every benchmark in Tech Empower, which is a public domain benchmark, not run by us, run by the community, and it shows our adherence to awesome performance standards. And then finally, who's new to .NET? Who are these growing people? Well, many of them are students that are picking up .NET for the first time, and we're super excited about that. You might ask, how big is .NET? We have over 5 million developers. And what's cool about that is we've added over 1 million in just the last year. And 600,000 of those new developers, well, they're .NET Core developers using our newest, latest platform. And as we added cross-platform support years ago, with the beginning of .NET Core 1.0, we're now seeing our customers really use that. You can see people building on Windows, Mac, and Linux, and you can see here in the slides, we have over 2 million people publishing to Linux using .NET Core. Now, I'm super excited today to talk about what we just released, which is the .NET 5 release candidate. This is the next version of .NET that brings a bunch of new capabilities to your applications. We have awesome support for building what I call a single file application. That's where you actually take your application, and you don't require .NET to even be on the machine at all. You compile .NET into your application, and you get a small single file executable that you can copy to any machine. The next thing is smaller container images. We're continually striving to make .NET run better and better in constrained environments. And so you can now make the smallest containers ever with .NET 5. And then we have amazing web and cloud investments, which I'll go into in a little bit. I'm sure you've heard terms like microservices and containers and Kubernetes. Well, we want to be the best for that for you. And then new platforms are coming out all the time. You've probably heard about ARM64. There's actual Microsoft products like the Surface X that run on ARM64. And we have native support for that now in .NET Core as well. Continued performance improvements are coming as well, and new language features. So we're super excited about this release. I also want to announce that we just released .NET for Apache Spark. If you don't know what Apache Spark is, it is a mechanism or a service for writing big data applications that crunch millions, if not hundreds of millions of rows of data. And historically, it was all designed for languages like Scala. But we've added great C# and F# support for it in .NET. And now it's publicly available. And we have awesome support for this in Azure Synapse in Azure. I also want to talk more about the performance improvements we've done in .NET. We've done a lot since we started shipping .NET Core 1.0. You can see here that between .NET Core 3.1 and now, we're 30% faster for socket connections on Linux. Serialization is a huge part of all the apps we build today that are doing web APIs. We've done a lot of work to improve that. It's about 20% faster than it was in .NET Core 3.1 with .NET 5. And then as you serialize large data, we want to make that faster. And you can see here, we're 3 times faster, and we're zero alloc, which means we're not allocating any memory, and hence your app's going to run even faster. And then, of course, a lot of our customers are familiar with .NET Remoting or WCF, and you ask, what is the solution in the .NET Core, .NET 5 landscape for this? It's gRPC. gRPC is very similar to WCF. It's contract-based, but it's cross-platform. It works on Node, works on Java, it works on Python, and it works obviously on .NET. And I'm super excited to say that we have the fastest implementations of gRPC on the planet. You can see by the chart here that we are right in here with Rust, Go, C++, and Java. This benchmark is actually done on a preview build, not our final build, and we expect to actually be at the very top of this chart for the final build. The last couple of years, we've been shipping .NETs at kind of random intervals. It's kind of confusing. When does one go into support? When does one go out of support? And so earlier this year, we kind of announced that we actually now have a fixed schedule. You can see by this, we ship every November. We shipped .NET Core 3.1 LTS in December of last year. but .NET 5 will be this November, .NET 6 next November, so on. And then every other release is what we call a long-term support release. If you want to stay on .NET Core 3.1, you can for 3 years before you have to upgrade to another version. If you want to stay on the very tip, you can always stay on the latest version if you want, moving every year. That's what we actually recommend. But we hope this makes it very predictable and understandable of when new releases are going to come out and the support policies for them. So I'm super excited to announce .NET Conf 2020. .NET Conf is our virtual conference we put on every year with the new release of .NET. This year, it's going to be November 10th through the 12th. That probably is kind of a hint that November 10th is the release date for .NET 5, since it's the start of the conference. It's an amazing conference. It's half put on by Microsoft and half put on by the community around .NET. And this year, of course, we're going to announce .NET 5 there and release it. You'll be able to download it that day. So please come and join, and you'll learn about all the new things in .NET Conf. Also, we do smaller .NET Confs as well. We just did one on microservices a few weeks ago, and we'll do more every couple of months as we move forward. Now I want to talk about the vision of what I call one .NET. We have too many .NETs at Microsoft. We have .NET Framework, and we have Xamarin for building mobile applications. And then my team a couple of years ago made another one called .NET Core, which we're all familiar with. But my vision moving forward is that we're going to take all these and merge them together into a single product, which we're calling .NET 5. And so you can see here, along the wave of .NET 5 and .NET 6, we'll take all of the Xamarin workloads and build them into .NET. And we've already taken all the features from .NET Framework we plan to move into this new platform already. And so what does this mean for you, a developer? It means there's one SDK. That one SDK will let you build a mobile application, a web application, a desktop application, console, all those workloads. No matter which workload you're building, they're all going to use the same base class libraries. These are the common APIs that you use when you build your applications today. If you're building a Xamarin app today, you're actually using a different BCL than you're using if you build a .NET Core application. We want to change that. And then many of our customers are very happy with the new project system we have in .NET Core, and we're going to make that work across the entire platform. Next is, we want .NET to have awesome cross-platform native UI. If you want to build an app that runs on Windows, Mac, Android, iOS, we want .NET to be your solution. Also, we want to have awesome cross-platform web support. If you're familiar with ASP.NET Blazor, it's our latest framework for building modern applications that can even run as desktop applications using the web. And then obviously, as I said before, Kubernetes, microservices, containers, we want to have great support for that in .NET. And then, of course, we're always trying to make it faster, smaller, better diagnostics, all of those things. And I think at the end of this 5 to 6 wave, we will be the best platform for any type of app you can want to build. What else is coming in .NET 5? Well, we have new language. C# is migrating to C# 9. And I've listed just a few of the many features on the slide here. One is records. Today, if you're building a web API and it needs to return a type, you probably create a class and that takes a file. Well, now we're going to let you do these things inline, so you can have a very small, succinct way of actually describing the return type you want. The next thing is, in a microservice world, you want your app to be as small as possible, least lines of code. And so you can see here we have something called top-level programs, and with it, I don't have to write all the ceremony in my app. You can actually build a microservice in about 10 lines of code with .NET using top-level programs. The next thing is cloud native. As I said before, all those buzzwords you hear, we think we're the best here. We have awesome support for REST APIs using the Open API spec, and I'll do a demo of that in a little bit. We have a REPL for debugging your APIs, and we can actually generate clients for REST as well. So write your server, and we'll generate the client code to call that. I mentioned earlier gRPC. That's a way of doing contract-based APIs, and we have the same features that we have for REST for gRPC. You write the proto file, which describes the API. We'll generate the server code for you. We'll generate the client code for you. And as I mentioned before, it is super fast. And another thing we're trying to do is we know that most of the cloud apps people are building today run on Linux. Well, what do you do if you're running on a Windows machine and you want to develop for Linux? Well, we just introduced earlier this year the Windows subsystem for Linux 2 in Windows. And using that, we built this into Visual Studio where you can actually develop your .NET projects in Linux directly on Windows. It's just as seamless as building it on Windows. You just select WSL2 and your app runs in Linux. It's amazing. And we've been trying to make our microservices smaller and smaller. So there's new features in .NET 5 that can get a .NET microservice down to about 18 meg self-contained. And then, of course, we want to make it easy to build microservices. These are apps that contain a front-end, multi-back-end applications. Our tools today are really geared towards a single app. And with Thai, we're going to enable you to use many apps and develop them the same way as you develop a single app today. And I'll do a demo of that in a little bit. And so here's what Project High kind of looks like. You can see here I've got my front end. I've got a couple of back-end services that know how to talk to each other. And so one of the things that High does is it helps you discover those services. It makes it where you don't have to figure out the IP addresses. The next thing is you might want things like SQL servers or Redis caches or those types of things. I don't want to install those on my machine. Well, you can add a single line and we'll bring it down as a container. And so you don't have to actually install it on your machine, which also means I can give the app to somebody else and it'll work on their machine too. Then we want to make it very easy to run locally. That means boot up all the microservices and the services they depend on your developer machine and let you run them all together and debug them, just like you could a single app before. And then we have an awesome dashboard as you're building these applications where you can actually see the performance of them, the logs of them, and find out the IP addresses so you can launch your browser to see them. And then the best part of this is we make it where it's very simple. I can really take a .NET project, containerize it, put it into Azure Kubernetes Service in about 20 seconds. I challenge anybody to do that with any other tech. I have one more announcement, which is something that's in public preview now, which is .NET for the Azure Spring Cloud. There's an awesome open source project called SteelToe, which helps people that are building applications in Spring. Spring is a Java framework, but many companies use Java and .NET both. And so this awesome service in Azure plus SteelToe, you can take your .NET projects and run them in there as well. And so if you're a mixed shop doing Java and .NET together, this is a great thing to look at as you look at building in the cloud. And now I'm going to do some amazing demos of some of the tech we just talked about. So the first thing I want to do is talk about web APIs and how we made them better in .NET 5. So what I'm going to do is I'm going to go into Visual Studio and I'm going to create a new project here and I'm going to select ASP.NET, call it my new web API, and I'll click Create. And of course, because I'm using .NET 5, I need to select .NET 5 here and I'm going to select an API. And the first thing I want to show you is there's a brand new option here. Look at this. This is Enable Open API Support. And Open API Support enables a lot of features like debugging and client generation and stuff like that. I'm not going to create this here. I'm going to just close this version of VS out. And I'm going to go to an app that I've already created here. So here's what that would have created right here in Visual Studio. And it's an API. But what's different this time is, let me just check here. And something new that happens on this API. Notice that normally when I run an API, I would just get a blank screen or an error in my browser because there's no web there, there's no code there. But now I get this nice dashboard where I can see all the calls in my API. I've just got one, get weather forecast. I can press the get button and say try it out here and press execute. And right here in my browser, I got to go call and test that API. So we're going to make that inner loop of working on APIs so much better. Now, I mentioned something that OpenAPI, it's a spec. So if I click this link here, I get to see this OpenAPI JSON format. This is a description of my API. And what I'm going to do here is I'm just going to take this and I'm going to save it to my disk in my download folder here, swagger.json. And I'll show you in a little bit what I can do with that. I want to show one more part of what we've added. Because of that Swagger, I can do other cool things. Like here, I can drop down and I can switch my browser to the HTTP REPL. And I've got that in my browser here. That's a NuGet package you can actually install, and it gives you a command line interface for actually trying out your APIs. So if I go back here into my project, let's go to my controller. Let's bring that up. And maybe I'll put a breakpoint inside of my controller here. And let's launch this again in Visual Studio. But now notice I get a nice command line interface. I can do dir and see what my API looks like. I can go into that folder for the weather forecast. And now that I'm in there, notice I can just type get. That makes the requests. The data comes to my screen just like that. So it makes it very easy for you to drive around and try your API out. I didn't start the debugger up. If I did, it would have actually stopped. But this is showing how easy it is to build and debug APIs in .NET now. Okay, so now that we've debugged an API, I want to show you how easy it is to use this same OpenAPI/Swagger to actually generate clients. So what I'm going to do is come back to my project. I'm going to right-click, and let's add a new project. And we'll do a console app here. The name doesn't really matter. We'll just call it test client. I want to write some code that can actually call that API that we just wrote. So we'll create this. It's got no code in it. But what I'm going to do is I'm going to right-click on my project here. And I am going to go to Add. And I'm going to select Connected Service. And there's this new option right here where I can select OpenAPI or gRPC to add them to my project. So I'm going to click Add. I'll select OpenAPI. And I need to go with that file that I put in my download folder. We need to grab that Swagger file. That's the definition of my API. And from that, we can generate the code for you. So I'm going to click Finish. Here we go. It adds a couple of packages and stuff, and I'm done. And now all I've got to do is go to the program CS, and let's write some code. Now, I wrote a snippet. You don't have to watch me write code. So let's do this. And here is my code. And so if you look here, got a few squiggles. Let's fix those. Visual Studio will help me with that. Include that reference, and because we're doing async, we need to make the method async. All the squiggles are gone now, and you can see here, all I do is I new up an HP client. I create a new Swagger client. That's what's generated for me by the tool. And then I can just call the forecast API very simply. So let's try that. To try that, I'm going to go to my solution. I'm going to set startup projects to run more than one. I need the server and the test to run together. So let's say this. We'll say start them both. I'll press OK here. And now what should happen is when I run Visual Studio, it'll create that API and start it running. It'll also run my client. There's my app running. I can now step into this. Look at that. Run over that code. Write that output out to the screen. If I go look in my console project there, you can see the results coming to the screen. So in just a few minutes, I was able to go and add an API client to my API. So we're making it super easy to build REST APIs. I want to show one more final thing from this aspect of it. We think of APIs even more than just being able to build them and all that stuff. We want to let you publish them to Azure as well. So I've got a project here, and I can click Publish on this API. I can select Azure. I want to use Linux here. I'll select Next here. And it's going to go out and find that I've already got a Linux app service up there that I'll publish it to. But this is brand new. Never seen this before. We can now publish your API to API management. So all I've got to do is open this up. And this is my instance of API management in the Azure cloud. Here's my APIs. I'm going to select my web API. And I'm going to press Finish. It's going to go create a profile for me. When I press this Publish button, not only do we publish to App Service, but we're also going to publish it to API management. So not only can you build an API, you can manage it with Azure API management. And that's what we have new in APIs in .NET 5. Another cool feature that we have in .NET is support for what I call static web apps. It's a new feature in Azure. And with ASP.NET Blazor projects, you can create a project that does not require any server. It just serves the static files down. The actual app runs in Blazor WebAssembly. It runs in your browser. It does not require a server at all. It just needs the static files. This saves you money because there's no compute resources being used to host the application. It all runs in the user's browser. So how would you do that with .NET? And so I've got an app here. It's a Blazor app, and I've written an API that would be an Azure function and a Blazor application. And we can run it here in the tool. And you're going to see that what happened behind the scenes here is we started up a emulator for Azure functions that's running locally. And here's my Blazor application. It's kind of cool. You can run around. Everything refreshes instantaneously. It's a single page application. It's a SPA. It's modern web. But how would you host this in Azure and do it with these static apps? So what I'm going to do is jump to the portal. And I've already got this set up. And so first I'll show a working version of it. Here it is. I can click the link, and you're going to see the same app running in Azure. There you go. It went and got the data and all that kind of stuff. But if I was going to build this in Azure, what I would have to do is, let's go back to the portal. And I'm going to go home here, and I'm going to create a new one of these. And I'll just search for static web. And then you can see the static web preview. .NET support is just added right about now. I'll click Create, and I'll just do one of these here. Let's do this. And I'll call this my static.net. And I'll select a region. We'll do East Asia. And then these static web applications, they work through GitHub. OK, so let's log into GitHub. We'll just do this. My password manager will fill all this in. I'm good to go. Let's authorize this. And so now what you're going to see is it found my GitHub repo. And I need to tell it what organization to use. And so I'm going to choose cool CSH. The repo, and it's going to be the Blazor static web app. And the branch of the repo, let's choose that. So what's going to happen here is static web apps is going to go out to my GitHub. It's going to pull that code down. It's going to create a GitHub action to pull that code for me. And all I have to do now is tell it how the app actually works. So I'm going to select custom here. And from here, I need to say, what's the app location? If you go back to my Visual Studio, I've got a client folder. That's my Blazor app. So I say whack client. For my API, I just do whack API, once again to match my Visual Studio. And then for where my web code, well, in a .NET application, your web code is in the www root folder. So we'll just say www root. And if I press review and create, it'll go and build a static web application for me. It'll run my API in an Azure function. It'll run my web application as a static web app with no compute resources, means no cost to you. And it's a great new way of hosting APIs in Azure and web apps. And so super excited about it. You can see the results here. It's pretty amazing. Try it out. Okay, so next I'm going to show Project Tie. It's a great way to run microservice style applications in .NET. Today our tools are great at building a single app and running it. But when you have lots of pieces, it gets complicated. So let's try that. So I'm going to switch to Visual Studio Code. And over here, I've got the solution up here. And you can see I've got a back-end project. I've got a front-end project. I've got a few of these things. And typically this means I'm going to make a mistake. I might come over to like a command prompt. I'm in my front end. I do a .NET run. There it goes. It comes up. I take this and I shove it into my browser. And of course, this is not going to work because I forgot to start the back end because we're not good at running lots of projects. So let's fix that. So I'll close the browser out. I'll go back here. Let's stop running the app. The app's not happy. And what I'm going to do is I'm going to go and add a few things. I'm going to do tie run. Tie is a new command you can run, and it will go and find all of my projects. So it went and found my front-end project and my back-end project and started them both. Great. It also gave me a dashboard. I've got this cool VS extension that knows about this. It'll launch the dashboard. Here I am. I can see my front-end project, my back-end project. I can look at the metrics for them. I can look at the logs for them. We're giving you more information than we ever have before. But if I run this, it's still going to crash. Dang it. I'll let it crash here. And it crashed because you can see here in my code, I actually hard-coded the front end to a port on the back end that I don't even know what that's going to be when the app runs. But Project Tie solves this. I can go to my CS proj. I'm going to uncomment this package. It brings in an extension for Tie to our configuration system. It needs to restore here. I'm going to go to my startup.cs, and I'm going to comment out that hard-coded line, and I'm going to bring a new one in. Instead of referencing localhost :22299, I'm just going to say backend, and I'm going to let Tie figure out what the port and IP address for that backend is for me. So I can save that, and so I should be good to go again. Go to my terminal here. Let's run tie run and see what happens. Building my projects, they're up and running. I'm going to rerun that dashboard. Look at that. Now the back end, the front end, they're all talking to each other. I don't have to worry about that. When I publish to the cloud, it all changes again, still clean. Now I want to add a dependency. I want to add a Redis cache. I could add a SQL Server as well, but I don't want to install that on my machine. So what I'm going to do is I'm going to stop this, and I'm going to type tie init. And when I do, Tie is going to actually create a file that describes how it runs. So if I go to tie.yaml here, you can see it's got a front end, it's got a back end, it points to my CS projects. That's what happened when I did tie run. It automatically discovered that and just did that. Now I'm going to add a little bit more flair to this. I've got this stuck over here. I'm going to add a new element to that. Paste this in right here. And what I'm adding is, notice I'm calling this Redis. It's got an image instead of a project. That's important. The image is a container image, not a CS proj .NET project. So it's going to go to the cloud, pull that down, and boot that up. Great. So let's go and take and save that. Let's go to my CS proj. I'm going to unreference one more item here. There you go. This brings in the Stack Exchange client so I can actually talk to that Redis cache. I'll go back to my startup, and I'm going to uncomment this code, which basically will configure that Redis cache and dependency inject it into my project. Notice, no connection string again. I just call it by the name from the tie.yaml file, and we do all that mapping for you. And all I've got to do now is save that, go to my front end, and I've got this tag helper around distributed cache. And what this tag helper does is tells ASP.NET to take all of this markup and keep it stored in the Redis cache for 5 seconds. So let's save that. So I've done all that work. And now what I'll do is go back over here and we'll do a tie run again. And this time it's going to boot up my 2 .NET projects, plus it's going to go grab that container and boot that container up running Redis, so I don't have to install it on my local machine. Let's go back to the dashboard, click refresh, and now you can see it knows I've got 2 .NET projects and a container, and they're all hooked together. If I go here and run the application, boom, app comes up, it looks great. I can press F5 to refresh my browser. Notice nothing changes. That's because it's cached in Redis, just like we wanted. Perfect. Okay, so let's take this to the final step. And what I'm going to do now is I'll close that out. And I've got this app with 2 .NET projects and a container. I want to run that in the cloud. So to do that, I can go to my command prompt here. We'll jump back a little bit. In fact, let me just stop the project running inside of VS Code. And what I'm going to do is I'm going to do tie deploy dash interactive. And this tells Ty to go take all of this and upload it to the cloud for me. It needs to know my container registry, so I give it the name of that. And so you can see it's creating Docker images for me. I never wrote a Docker file. It's doing it all for me. It's now saying that, hey, I need to do this Redis thing. Where's your Redis? And so let's go back up here. Go to portal.azure.com. Sign in as me. I'll select my Redis cache. I'm going to show you my connection string, but by the time you see this, I will have deleted it, so you can't have it. And what I'll do is I'll paste this in. You can see it's pushing all the Docker images. And it's actually running in the cloud. Now, I forgot one step, and let's go fix that. While it is running in the cloud, I can't hit it because there's no public IP address for that. So let's take it back down. It's kind of fun to show how fast I can do that. Tie undeploy. All comes down. Take it out of the cloud. Awesome. And I'm going to make one more change to my tie.yaml file. I'm going to go add this block in as well. And I'm going to create what's called an ingress. And that's how you actually get into a Kubernetes cluster. So let's go here. Paste this in. Well, paste it in up here, actually. And if you look at this, what it basically says is it has a name, just like everything else. We bind it to a port. And we tell it, if you hit the whack of the IP address, we want to forward the traffic to the front-end service. So I save that. This looks pretty good now. We'll go back. I'll run tie deploy one more time. You can see all this going. I'll give it my registry one more time. And I know it's going to ask for that connection string to my Redis. I'll grab that one final time, stick that in. There we go. Okay, let's check kube control. Let's give it a second. Let things kind of process on the server. And we'll go and ask if we can get access to that public IP. There it is. And so all I'm going to do now is grab that public IP address, put it in my browser, and there you see, I've got this application running in Azure Kubernetes Service. I went from running it on my local machine to running it in Kubernetes in, I don't know, 1 or 2 minutes. It's that simple with Project Tie. Okay, to recap, where are we at? .NET 5 begins the journey of unifying .NET into a single platform again. We have shown how .NET has amazing performance and is great for microservices with Project Tie. And I just showed how REST and gRPC are super easy for productivity and for debugging with .NET, and single files make awesome microservices, and Tie can help you build and publish these microservices to the cloud very, very quickly. I recommend everybody try to go grab the RC, download it and try it out, and please give us feedback. Thank you very much.